Okay students, good morning. So as you can see, our today's topic is a new chapter, that is chapter 3, unit 1 of chapter 3, and the chapter name is force and the pressure. So before starting, of course we need to know what is force. What is force? Can anybody define? Okay, if you define, that is good, but let me define again. What is force? Let me first explain what is force. Suppose this is an object. This is an object and I want to displace the object. What I have to do? I have to give something on it. I have to apply some physical quantity. I have to apply something on it, and that thing which I am applying on this object to change its position. Okay, so that is force, and that is denoted by capital F. So what is the definition of force? The definition of force is: a force is that physical cause which changes or tends to change either the size or the shape or the state of rest or of motion of the body. Okay, so we shall deal with the force in next classes, but this is the basic definition of force, and that will be available in the description of the video. You can go there and note it down in your copy. Okay, so in this whole chapter we shall deal with various consequences of the force. So the first thing that is starting with your with this chapter in your book, that is the turning effect of the force. What I am saying, the turning effect of force. Turning effect. So turning effect of force is basically known as the moment of force. So there is another name of turning effect of force, and this is more popular. This is moment of force. So what is the definition of moment of force? The turning effect of a single force about a fixed point. So what is that? The turning effect of a single force about a fixed point. What that mean? Let's say, suppose this is a thing. Suppose this is the thing. I am applying a force here. Suppose this point is fixed somehow. I am applying a force here. So what will happen? It will turning. So this is the turning effect of the force. So actually what that mean? The turning effect of a single force about a fixed point. Let's say this is a stick is kept here and this is the fixed point. This fixed point has a special name, and that is pivot. P-I-V-O-T. So this fixed point will be known as pivot. Now I am applying a force here. Let's say the amount of the force is F. I am applying a force here. Okay, and if the length of the stick is L, then this force F will produce a moment, means a turning effect. That's when it is fixed here. You just want to, you are pushing it with the force F, so it will rotate, right? It will rotate along this direction. So this will be known as the turning effect of force, or better to say the moment of force. Okay, now just look very carefully. The moment of force depends upon two facts. What is this two fact? Number one is the amount of force we are applying, that is F, amount of force we are applying. And number two is the length of this force, basically length of this rod, and it is known as the perpendicular distance from the pivot to the line of action of force. This is the line of action of force and the perpendicular distance between these two. Let me give another example. Suppose the pivot is here and the rod is like this. This is of length L. Now I am applying a force here. Just look at this, the consequence a little bit different. And what is the difference between the point O and the force here? I have just said the perpendicular difference. That's mean this is the distance. Okay, now this is the perpendicular distance. So the perpendicular distance, not the length of the rod. The perpendicular distance from the pivot to the line of action of the force. And we shall take it as D. That's mean the difference or distance, whatever you take. Okay, so this is the perpendicular distance. Okay, so perpendicular distance, must keep it in mind, not the length of the rod or something like that. So here in this special case the D and L will be same, but this is the actual consequence. Okay, so the two factor you need to know, and that is important for exam. Now this turning effect of force or the moment of force is denoted by the symbol M. Okay, and that will be F into D. So this is the value of moment of force. So moment of force, that is equal to force into perpendicular distance between the pivot and the line of force. Is it okay? So this formula is very much important. Here this M is the moment of force. This formula is important for numericals. Okay, I shall give you numericals, and that will be in form of PDF. Okay, next. So let's consider a different case. Okay, now instead of a single force, if we apply two equal force, what will happen? If we apply two equal force, what will happen? That's mean, let's say this is the thing and we are applying two forces. One is from this side and another is from this side. We are applying two forces. So what will happen? One is along this side and one is along this side. So this will rotate now. Again, this is making a turning effect, right? But this turning effect has a different name. This name as torque. Okay, so the new physical quantity we are getting here, that is torque. TORQUE, that is torque. Okay, so how to define it? Let's say this is the rod. This is the rod here, and we are applying a force from here and another force from here. Okay, you have to keep one thing in mind, that these two forces must be of same magnitude. If these two forces are of different magnitude, then there will be a different type of motion. That's mean either the rod will go along this direction or along this direction. It will rotate, but it will displace also. So what is how the torque is defined? What is torque? So a pair of equal sized turning forces acting on different direction. So equal sized turning forces acting on different directions is called a couple. So these two forces will be called the couple, and the turning moment caused by this couple will called the torque, and the turning moment caused by this couple is called the torque. And again here, let's say the distance between two line of forces is D, and let's say if the rod is like this and the forces are acting along this direction, then the line of force is distance between the line of force is D. Then here the couple, actually the couple is denoted by the same formula, that is moment of force, and here of course the torque, that is equal to force multiplied by perpendicular distance. Of course you have to take the value of a single force. Okay, basically it is the same case here. When you are applying a force along this direction, that's mean, let's say this is the case, it is pivoted at this point. When you are applying a force along this direction, automatically a force of reaction will act along this direction. Okay, actually that is the topic of different chapter, that is on Newton's third law, and we shall discuss it in next class. Next class means in upper class, in class 9 you have this, but just leave it for now. Okay, so you have to solve a few numerical problems regarding this formula, with this formula. Okay, and we shall do that later. Okay, and a few numericals are also given in your book with a few investigations. Actually that investigations are not important for exam, but you have to read the outcomes of the investigations. Okay, so the next topic we shall go with pressure. So the next topic we shall go, that is pressure. PRESSURE, pressure. So what is pressure? We have to know. We are giving something on it, that means I am giving pressure on this page. We often say like that, but we have to know in different manner what is this pressure actually and how to calculate it. Okay, let me tell you in one word that pressure, that is equal to force by area. Force by area. So how to define this pressure? The thrust acting per unit area is called the pressure. So what I am saying, the thrust, THRUST, the thrust acting per unit area is called the pressure. Now what is this thrust? What is the difference between force and thrust? Basically, thrust is the force acting perpendicularly. Thrust is the force acting perpendicularly. Means suppose this is a plane, a force is acting like this. This is not thrust, but if a force acting perpendicularly, that is thrust. This is thrust. This is thrust. Okay, but this is not thrust. Okay, whatever. This is a simple force. So what is pressure? The thrust acting per unit area is called the pressure. So we are getting the formula from here. Pressure equal to force by area. Pressure equal to force by area. Okay. Oh, sorry, I missed one thing. So what will be the unit of this moment of force? What will be the unit of this moment of force? This is very easy actually. This is unit of force multiplied by unit of length. So in SI it will be Newton meter. In SI it will be Newton meter. And in CGS, what is the unit of force? That is dyne, and the length is centimeter. So in CGS, this is dyne centimeter. So the units are important. Okay, the units are important. So what is the unit of moment of force in SI? This may be a question, short question. Okay, or in CGS, this may be a short question. Rather, you need it in to solve numericals also. Okay, so this is pressure. Now what is the unit of pressure? What is the unit of pressure? Basically, unit of pressure, that is the unit of force by unit of area. So unit of force, so in SI, unit of force is Newton. We know unit of pressure is Newton. And what is the unit of area? That is meter square. So Newton per meter square is the unit of pressure, and this is SI unit. Newton per meter square is the unit of pressure, and this Newton per meter square is known as Pascal. This unit of meter square is known as Pascal. Okay, and this is sometimes denoted by Pa. Okay, so this is Pascal, and it has another form, Newton per meter square. Now what will be the CGS unit of pressure? The unit of force in CGS, that is dyne divided by centimeter square. So dyne per centimeter square is the CGS unit of pressure. Is it okay? Now I shall give you a work. Find the relation between Pascal and dyne per centimeter square. That's mean 1 Pascal equal to how many dyne per centimeter square? Okay, calculate it now and tell me now. Okay, you can post in comment section also, or in WhatsApp group, whatever you want. Okay, so this is the question. Do it now, solve it now. First pause the video and solve it first, then we shall calculate. Now you will find that in your book some special calculations are there. That's mean calculation of pressure in few simple cases. Okay, you will find one example is here. One is for a girl, and next you will find for elephant, and after that you will find a case of a camel also. You will find a case of camel also. Okay, so basically how this works. Okay, let's say in case of a girl, actually these are about the shoes. Okay, shoes, that's mean if you just look at this figure very carefully, that's mean the heel of the girl shoes is sometime like this. That's mean very sometimes like this, the heels of a girl shoes. Just look at this here about the areas. We are talking about the areas. Okay, so before that we have to discuss something else from here. What is that? Just look at this, pressure equal to force by area. So when the pressure will increase, if you increase the force, the pressure will increase. Of course, that's mean pressure is proportional to the force. So if you increase the force, the pressure will increase. and the pressure is inversely proportional to the area. That's mean if you decrease the area, the pressure will increase. Okay, if you decrease the area, the pressure will increase. Is it okay? If you decrease the area, pressure will increase. Now look at this case. This is the heel of a girl's shoe. Here the area is very small, so that is why the pressure is very high. Similarly, in case of a leg of an elephant, in case of the leg of an elephant, so leg of an elephant, basically it is of the value of area is little bit high. The value of area is little bit high, so that is why the pressure in case of a elephant given by the leg of the elephant is of smaller value. Okay, is of smaller value, and sometimes this is smaller than the pressure of the heel of a girl's shoe. So that's mean pressure given by an elephant is less than the pressure given by a heels of a girl's shoe. Is it okay? Okay, now let me tell you one thing. Suppose some sands are here and you are traveling through a desert. Okay, the girls are wearing this type of heels. So what will happen? Actually, their leg will stuck into the sand. But look at the leg of the camels. Look at the leg of the camels. The leg of the camels, actually the lower side of the camel's leg are of bigger area. So just to reduce the pressure. Okay, you will find tractors have a very thick wheel, right? Tractors have very thick wheel so that they can easily get rid from the mud. Okay, the pressure will be low, the force will be distributed among the areas. Okay, just to reduce the pressure. There are a lot of examples are here. You will find examples on skis on snow, ice skis on snow, right? This is the same thing. Now let me tell you another thing. If I want to just do like this, that's mean from this side of the pin and from this side of the pin, which is more dangerous? We know this side is more dangerous than this one. Here the same case, if I hit you with this side, if I hurt you, so it will be more severe than this one. It may wound you, but it will not. Why? Because the area of this nib is very smaller than this part. Okay, so here the pressure will be less, but here the pressure will be very high. So it will make the wound, but not this one. Is it okay? In case of a knife also, a cutting instrument, you know, such as knives, blades, axes, picks, etc., are sharpened from cutting edge. So what happened if we sharpen the edge? Sharpening the edge means reducing the area. So that's mean reducing the area means increasing the pressure. So that will help to cut. Okay, similarly if you talk about pin, so the pin is also like this. So just reducing the area to increase the pressure. Okay, so this is the end of the first unit. Okay, I am giving just I shall upload the PDF regarding this topic, and a link will be given in the description also, so that you can download the PDF. Okay, thank you, bye. And we shall discuss now. Oh, by the way, I am just uploading the video in the YouTube channel because the size will be, the video will be little bit big. Okay, moreover that you can find all the videos of previous classes also here in this playlist. I shall share the link. Oh, of course, please subscribe the channel, that will motivate me. Okay, thank you students, bye. Let's see in WhatsApp group. Okay, thank you.